All right, hello again. So this is part 4. We are subtracting with different denominators. Okay, so following the rules, first we have to factor the denominator. Well, neither one of these factors. Okay, their GCF is 1. So we're going to set them both equal to 0 to find what x cannot be, just like we did in the previous 3 examples. Okay, so setting them equal to 0, we see that x cannot be 5, nor can it be -3, because that would make either of those denominators 0, and we can't have that. Okay, so then to find the LCD, acknowledge what they have in common and what they have that's different. Well, they both have different denominators. Nothing is common, so that's our goal. Now, what do I need to multiply to this fraction to get this LCD? I need to multiply x plus 3. So I'm going to say x plus 3 over x plus 3, and I'm going to multiply it to 2 over x minus 5. On the right hand side, I have a minus, and I have x minus 3 over x plus 3. So that means I'm going to have to multiply it by x minus 5 over x minus 5. Now I know it says to distribute the negative first. I'm going to do things in a little bit different order if that's okay. Well, I am. Okay, so distribute the 2. So we get 2x plus 6 minus this whole thing. When you multiply it together, you get x squared minus 8x plus 15. Now I put it in parentheses because that shows me that I'm going to have to distribute the negative. And in the denominator, we get x plus 3 times x minus 5. Okay, go ahead and distribute that negative. So we get 2x plus 6 minus x squared plus 8x minus 15 all over the denominator, which is x plus 3 times x minus 5. Okay, combine like terms. So we get negative x squared. 8 and 2 gives us a positive 10x. 6 and negative 15 gives us a negative 9. All over x plus 3 times x minus 5. We can factor out a negative 1, and that leaves us with x squared minus 10x plus 9, which doesn't factor because there aren't two numbers that we can multiply to a positive 9 and add to a negative 10. Yay! Okay, if we look at this one, okay, well, I can't factor anything out. I know that x, since these are all products, I know x can't be 0 and y can't be 0. Those are my restrictions. These had numbers adding and subtracting, so we had to move through inverse operations. This one's all products, so we know anything multiplied by 0 is 0. The variables can't be 0. Okay, so what's the highest number of x's we have? 3. Okay, so we know x to the third has to be in it. Y squared and 2. The goal is, like we did previously, to acknowledge what they have in common and what they have that's different. So on the left-hand side, in order to get 2x cubed y squared, I need a 2. I need 2 more x's. And that's what I'm going to multiply in order to get, oopsies, in order to get my common denominator. Okay, minus 7y over 2x cubed. Well, it has the 2 already. It has the x cubed. It just needs the y squared. Okay, so then on the left-hand side, we get 10x squared minus 7y cubed all over that common denominator because we took care to make sure that we had it. And there's nothing we can factor out or reduce. You can't reduce the x's because this is a quantity. Be careful with that. All right, last one for subtracting. We actually can factor. Two numbers that multiply to 15 and add to 8 is a positive 5 and a positive 3. Okay, so we know that c plus 5 is in my denominator, as is c plus 3. So c can't be negative 5 and negative 3. What makes that denominator equal to 0? Okay, so our common denominator, acknowledge what they have in common, and acknowledge what they have that's different. So this is my goal, to get my denominators to have what they have in common and what they have that's different, like we've been doing. So on the left-hand side, I need to multiply a c plus 3 over c plus 3. And on the right-hand side, I don't need to change anything because it already has both factors. Yay! If you do want to, you can always do 1 over 1. That's fine. So distribute the c. We get c squared plus 3c minus 4 all over c plus 3 times c plus 5. Two numbers that multiply to -4 but add to 3. Let's see, -4 and +1. Gosh, no. What about +4 and -1? Would that work? Let's see. C plus 4 and c minus 1. That works. So after factoring, I see that we can't cancel anything else out, so that's our final answer. Awesome.